myself Maitri Dave, Assistant Professor at LG Institute of Engineering and Technology. Today we are going to discuss the civil engineering materials, right? So let us begin our lecture number 4 for that. So here I can say for steel, that first question arises in our mind that what is steel, right? Then we will see the different types of steel, and then we will see the uses of steel, and lastly we will see the market forms of steel, right? So let us understand first what is steel. So here on screen you can see this is the picture of steel, right? Where steels are essentially alloy of iron and carbon, but they always contain other elements either as impurities or alloying elements, right? So here steel is man-made metal containing 95% or more iron and 0.1% to 1.5% the carbon. Smaller amount, it means around 1.6% of manganese and nickel to improve the certain properties, right? So that is the ingredients of steel. Now here the carbon improves the strength and the hardness but reduces the ductility and the toughness. So it is an intermediate stage of cast iron and the wrought iron, we can say. Here the cast iron can take compressive strength while the wrought iron can take the tensile strength. So here we can say that steel is suitable for all construction processes, right? So it is highly elastic, ductile, malleable and the weldable one, right? So it has the high tensile and the compressive strength, and again it can resist wear and tear much better than the other metals, right? So that is all for the steel. Now let us move to the second one, which is different types of steel. So here I can say different types are there according to the carbon content, where the first one is the mild steel. So here I can say that carbon content is all about 0.1 to 0.25%, where the properties of mild steel are in such a way that it is ductile and malleable, even it corrodes quickly, it can be permanently magnetized, it is tough and more elastic than cast iron and wrought iron and withstand shocks and the impact well, right? Even it is equally strong in tension and compression or as well in shear, right? So we can say here the specific gravity is all about 7.8 of mild steel. Even it is not much affected by the saline water. So we can say these are used in nails, screws, car bodies and the structural steel. So that's all for the mild steel. Now let us understand the medium carbon steel, where here it contains up to 0.25 to 0.75%, right? Where the properties are like welding is difficult, more elastic in comparison to mild steel, even more tougher comparison to the mild steel. It withstands shocks and the vibrations, permeably magnetized, stronger in compression than in tension. Even the compression strength is about 80 to 120 kilonewton per centimeter square, right? So it again used as a structural steel, rails and the garden tool. So that's all for the medium carbon steel. Now the next is the high carbon steel. Again, here the carbon content is all about 0.75 to 1.1%, right? Where the properties are like in such a way that its structure is granular, it is more tough and elastic than the mild steel, it is easier to harden and then to weld, it is more difficult to frog and then to weld, it can be permanently magnetized, comparatively it can be stronger in compression than tension in the shear, right? It withstands the vibrations and shocks better. Again, these are used in hand tools or we can say the shop blades, right? So this is all for the high carbon steel. Now let us move to the next term, which is use of steel. So here I can say different uses of steel are there. Like it used as reinforcement for concrete, even it is used in steel pipe or the tanks, even it is used as a structural material in trusses and beams, right? It is also used in the sanitary and the sewer fittings. It is used as non-structural material like grills, doors and windows. Again, it is used as corrugated shields. So that's all for the uses of steel. Now let us see some market form of steel. So here I will show you some different market forms, where this is the flat bar, this is the angles, this is the round bar, this is the hexagon bar, this is the sheets or the plates of steel, these are the channels which are very much useful. Even these are the wide flange beams, I beams are there, right? Here you can see the I shape. Even some square tubes are used, round tubes are there, right? Even this is the chamber bar, this is the T-bar, this is the half oval, and this is the rebar, right? So these all are the form of states. So let us understand first, that is what is mortar, right? Then we will see different types of mortar. Then we will see the functions of mortar, and lastly we will see the qualities of a good mortar. So let us understand first what is mortar, right? So here I can say in this figure you can see this is the mortar, where mortar is a material used in the masonry construction to fill the gaps between the bricks and the blocks used in the construction, as shown in this figure, right? Mortar binds bricks and the blocks together to give strength and stability to a wall. A mortar joint ensures the bond between the compressed or block, and this bond gives the masonry its cohesion, right? Mortar is a mixture of sand, a binder such as cement or lime, again the water. So generally it applied as a paste when then sets hard. So mortar is a workable paste which is prepared by adding required amount of water to a mixture of binding materials and the fine aggregate. It means this sand, right? So this plastic paste is useful to hold the building material such as stone or the bricks together, right? So that's all for the mortar. Now let us understand different types of mortar. So here various types are available, in which the first one is the lime mortar, second is the cement mortar, third is the gypsum mortar, and fourth one is the Sukhi mortar. So here let us understand first the lime mortar. So generally in case of lime mortar, lime is used as a binding material. So there are two types of lime, namely the fat lime and the hydraulic lime, right? So generally the fat lime in lime mortar requires 2 to 3 times of sand, and it is used for dry work. Generally the hydraulic lime and sand in proportion of or the in ratio of 1:2, which will give good results in damp conditions and also suitable for waterlogged areas, right? The lime mortar has a high plasticity, so it can be placed easily, right? So that's all for the lime mortar. Now let us move to the second one, which is cement mortar. So here as you can see on screen, in this type, cement is used as a binding material and sand is used as the fine aggregate, right? So the proportion of cement and sand is decided based on the specified durability and the working conditions, right? So cement mortar will give high strength and resistivity against the water. The proportion of cement to sand may vary from 1:2 to 1:6, right? So that's all for the cement mortar. Now let us move to the gypsum mortar. So here I can say, as shown in this figure, the gypsum mortar contains of plaster and a soft sand as binding material and the fine aggregates, right? So here in the gypsum Asian structures called as the pyramids, gypsum mortar is used. Gypsum mortar will have low durability in damp conditions. So that is the disadvantage. So that's all for the gypsum mortar. Now let us move to the last type, which is Sukhi mortar. So here you can see the Sukhi is something which is in a powdery form. So it is a finely powdered burnt clay which is free from any admixtures or the impurities, right? So it will give more strength than sand and cheaply available in the market, right? So Sukhi mortar contains lime, surki and water. So we can say that surki is used as a fine aggregate here. Sometimes half amount of sand and half amount of surki is also used in this kind of mortar, right? So that's all for the different types of mortar, which are lime, cement, gypsum and surki. Now let us move to the functions of mortar. So here I can say different functions are there, in which the first one is it provides binding force or the cohesion between the structural units. Again, it is act as a medium for distributing the force throughout the structure uniformly. We can say additional strength and the resistance against rain penetration and other such weathering agencies can be made, right? Even in stone or brick masonry, it filled up empty joints. A thin liquid mortar used for such purposes is termed as grout, right? The fifth one says is it does pointing or plastering to the structure. So these are the functions of a mortar. Now let us move to the last topic, which is qualities of good mortar. So here I can say the first quality is in such a way that it should be easily workable, Again, it should set and harden quickly so that construction could be done with speed. Even it should not develop any cracks on the drawing. It should be durable. Again, it should be capable of developing the design stresses. It should be capable of resist penetration of rainwater. And again, I can say lastly, it should cheap and economical, right? So these all are the quality of a good mortar. So that's all for the mortar.